Hello guys, assalamu alaikum. Today I will discuss about a problem. The name of the problem is max tree. So you are given a tree. Which has n vertices, and you have the ages one n minus one ages. So I will show you an example and discuss what the problem actually says. Let's say consider this second test case. These are the ages 1 and 2 are connected, 1 and 5 connected, 2 and 4 connected, 2 and 3 connected, and these first value is x, the next value is y. You can choose any of these. You can choose either x or either y. You can choose either x or either y, either x, either y, either x, either y. So in such a way you will choose one from each x and y, and you need to maximize the sum of all of this. Let's say I have chosen 3 from this, I have chosen 2 from this, I have chosen 7 from this, and I have chosen 100 from this. So the answer will be so the maximum value will be 3 plus 2 plus 7 plus 100. So when we can choose this y and when we can choose this x, here we have given a condition. Then we can choose x if the permutation value of the u is greater than the permutation value of the v. Let's say we can choose this x if the permutation value of 1 is greater than the permutation value of 5. So I will show it in whiteboard. Let's say consider this and consider this. So we can choose x, means here 2, if the permutation value of 1 is greater than the permutation value of 5. Let's say the permutation value of 1 is 3 and the permutation value of 5 is 2. Then we can simply say the permutation value, as the permutation value of u is greater than the permutation value of 5, we can simply choose these two. Okay. And for every case this is the same, and now we have to print that what is the permutation value of 1 to n. Here the permutation value of 1, I have arbitrarily chosen a number, but we have to make sure that what number we have taken in the permutation value of 1 should be greater than the permutation value of 5. And for all the test cases this holds. So how can we solve actually the problem? I will simulate it. Okay, let's say we will form a tree, a topological sort, where we will put the numbers or vertex of the less permutation number, and as we go down the permutation number of that vertex increases. So okay, first we have to choose this y. So when we will choose y, if the permutation value of 2 is greater than the permutation value of 1. So uh, which permutation value is lesser, we will take it as a source, and we will draw a vertex from 1 to 2. The permutation value of 2 is, as the permutation value of 2 is greater, it will be work as the reach point. So we will take 1 as a source and 2 as the reach point, because the permutation value of v must be greater, as we have to choose y. So we will take 1 as a source and draw a line from 1 to 2. Why we have drawn a line from 1 to 2? I have firstly said that the permutation value of the upper portion, means the upper layer, should be less, and the permutation value of lower portion should be greater. So as I have to choose these three, that means the permutation value of 2 must be greater and 1 must be lesser. So 2 must be greater means it will be located at the downwards of the tree, and 1, as it has the less permutation value, it will be located at the top of the tree. here we have to choose 2, that means the permutation value of 1 must be greater and 5 must be lesser. So that which is lesser should work as source and 1 should work as a reach point. So here 5 is the source and 1 will be work as the reach point, so it will be like this. Then we have to choose 7. So what will work like a source and what will work like a reach point? Here we have to choose 4, meaning the permutation value of 4 should be greater, so it will work like a reach point, and 2 will work like a source. 2 to 4, 2 will work like a source and 4 will work like a reach point. Okay, then we have to choose 100, means this permutation value is greater and this permutation value is lesser, so 2 will work as a source and 3 will work as a reach point. 2 will work like a source and 3 will work like a reach point. Yes, now we have formed a tree. If we topologically sort this, then we will simply get the permutation value. The permutation value of 5 must be 1, it must be 2, because the permutation value of 1 is obviously should greater than the permutation value of 5. We have seen this. The permutation value of 2 should be 3, and you can choose any of these 4 and 5. I will choose this 4 and I will choose this as 5. So we need to print the permutation value of 1 to n. So what is the permutation value of 1? That is 2. What is the permutation value of 2? That is 3. What is the permutation value of 3? That is 5. What is the permutation value of 4? That is 4. And what is the permutation value of 5? That is 1. So the answer will be like this. And yeah, 2 3, the second case answer is 2 3 5 4 1. 2 3 5 4 1. Okay, I will show you my code. Let's see. Okay, I will copy it and paste it to my code. So what I have done here, first I have taken adjacency to the vector, then I have taken a in degree, and I have taken this. You can you can simply comment it down because I have not used it in my code. Okay, then if the x is greater than y, that means we have to choose parent as a source. What we need to choose as a source, here the parent value is greater and the here the parent value is greater. I will show the code again. Okay, if the x value is greater, where is my second case? Yeah, if the x value is greater, that means the permutation value of 1 is greater and permutation value of 5 is lesser. So what will work like a source? The lesser value. That means the second value will work like a source and 1 will work like a endpoint. And that I have done. I have taken the second value as a source and the first value as a reach point. And in the other case the opposite will happen, and as we are going forward, we are check that in degree plus plus, as if what example we have seen, we have seen that 5 will as 2 is greater, this permutation value will be greater and this permutation value will be lesser. So 5 will work like a source and 1 will work like a endpoint. So 5 and 1, and the integrity value of this one is 1. We will actually calculate the integrity of all of the vertices. The integrity of 2 is 1, in the integrity of 4 is 1. In such way we will calculate. If there was something like this, 2 and 3 4, then what will happen? The integrity of then 2 will be, sorry, the integrity of 2 will be then 2. We will actually calculate it in this way. Then what will happen, we see what is our root. Our root is such a node which have 0 integrity. Let's say I have an example like this: 1 2 3 4, then 5, then 6, and then 7. So what will be our root? Here 1 may be our root, 2 may be our root, 3 may be our root, and 4 may be our root, because everyone's integrity is 0. So each of them can be our root, so we can arbitrarily take one of them as root. But instead of taking arbitrarily one of these to our root, we will take all of them in our queue. So as if the vertices has 0 integrity, then we will simply push it to our queue. We have taken a serial vector and we will run a loop. So what the loop says, first of all we'll see this example. Here first the queue have 1 2 3 and 4. Then if we simply say that these are taken in the serial vector, we'll sort it serially. Like first we will input all of this first layer, then the second layer, then the third layer. It is simply like a BFS, but I will show that there are some key points to notice, that why we cannot use BFS. But like BFS, we can use an algorithm, and the name of the algorithm is Kahn's algorithm. So here you see, if we take this layer, that means we have taken all of this, then what the integrity of this and this will be, it will be 0. So it will work like a source. Then we can take all of this, then what the integrity of this, it will also be 0, and then we will take this. In the simple logic we will apply here. We have taken the front value, and we have pushed in the serial, we have popped it, and then pushed it in a serial vector, as we want a serial, that which number is coming first, then which number is coming next. So we have pushed it in serial vector. Then what we have done, we have go through the child of that vertex, let's say child of that vertex, and we have removed 1 degree of that child. We have iterated all the child vertices, and we have actually minused in degree of that child vertex by 1. And if we simply say that the child has now 0 vertex, that means it is working like a source. Now we can simply push it to next. Here by iterating all of the queues, we can here iterating this and this, we can simply say that this vertex will have no integrity, means 0 integrity. First iterate this, then put it to serial vector, then iterate to this, put it to serial vector. And if we iterate to this, by iterating this, the integrity of this will reduce by 1, means 2 to 1. Then if we iterate this, the integrity of this will become 0. So we will push it to our queue. Okay, then we have popped it, then we will iterate through 3, we will put it to serial vector 3, we will pop it, and we will move through all of the child vertices that it has. It has the child vertices 6, which have in degree of 2. We will minus it, so the integrity of 6 will now be 1, and 3 will be popped. Okay, then we will iterate to 4, we will push it to 4, we will actually pop it, and we will iterate to the child of this 4, and remove the integer of that by 1. So we'll remove the integer of this, and as the integer of this become now 0, so we will push it to our queue. Then we will iterate to 5, then put our serial to 5, copy it, and then we will check the child of this and remove the integer of that child by 1. Then we will iterate to 6, we will push back to our serial 6, we will copy it from our queue and iterate through our child and reduce the integer of the child by 1. As now the child has 0 integers, we will push it to our queue. Then we will iterate to this 7, push it to our serial. As it has no child, the queue will not go forward again. So this is our serial vector. Now in this way this works. As we have, if we get a serial like this 2 3 like 4 1 5, that means the these two will come first, these three will come second, and so on. So but I have to say what is the permutation value of this one. So the permutation value of 1 is 1 2 3 4. So 4 will be, what is the permutation of 2? That is 1. What is the permutation value 3? That is 2. What is the permutation value of 4? That is 3. What is the permutation value of 5? That is 5. So we have to put this answer. So as we have moved forward from our serial, we have saved that in which number it has come, and as it is zero based indexing, the serial has been pushed down, and that is zero based indexing, so we have taken it to 1 based indexing, and at last we have outputted all of the vertices answer, means permutation value. So this is the Khan's algorithm, but I will now show that why the normal BFS doesn't work. So we will see an example. Let's say we have somehow made a tree like this, 1 2 then 3 then 4. Simply we have made a tree like this. So these are the roots. So our key has now 1 and 2. If we run it in Khan's algorithms, what will happen? 1 2, then it will be removed, then 3 has 0 in degree, then come 3, and then at last it come 4. If we run it in Khan's algorithm, we will get a serial like this. But if we BFS, sorry, 4 and this, and as Khan algorithm we have got this 3 4. So what will happen? In BFS 1 and 2 will come first, then 1 will loop, and then come 4, because in BFS we check it as a layer. So what 4 has, it will simply run it through. So then come 4, and 2 has 3, and 3 has 4, but it has already visited, so it will not move forward. So by BFS we will get a serial like this, which is not correct, so we cannot use BFS here. And I have checked it by doing a BFS and got a wrong answer. Okay, thank you. I hope you have understand the video well.